You can't have acceleration without a force according to Newton, so how do you explain that?
So, Rachie, listen up to what Blue says now about the force and acceleration, the thing that you are pretending to not understand because you're an attention-seeking troll.
Yeah.
Rachie, I want you to put two of Newton's equations together, if you would. His second law, which says force is equal to mass times acceleration, and his law of gravitation, which says force is equal to, or proportional to, the product of the masses divided by the square of the distance between them. Now set those things equal to each other. You've got mass times acceleration equal to the product of two masses divided by the square of the distance between their centers. You get rid of one of the masses and you're left with acceleration equal to mass divided by the square of the distance between it and whatever it's attracting. That's where it comes from. This is Newton.
Right, but Newton said there was a force. So is there a force, yes or no?
Do you want to run it right? Maybe you should write this down, Rachie. Do you want to just run for it once more, Blue?
Yeah, write this down. Okay, write the two equations down, Rachel. Write Newton's second law down, which says F equals ma. Okay, Greg, you can do this. You got the. I don't have a whiteboard.
Okay, can I just stop you there? Where did you get the A without a force?
We're just talking about Newton's laws here.
Wait a minute. Let's
yeah, where did you get the A without a force? Remember, A has to be caused by a force. Yeah, I'm just asking. You're saying F equals ma. Yeah. I agree. But where did you get the A from to begin with without a force? Right. Yes, but where did you get the A from without a force?
Now let's go ahead.
Where did you get the A from without a force?
Be quiet, Rachie, and just listen. Rachie, just be quiet and listen. Rachie, just be quiet and listen. Rachie, just be quiet and listen.
Where you got the A from? Where did you get the A from?
Rachie, from F equals ma, from Newton's second law.
Yeah, where did the A come from?
From Newton's second law.
So where is the force that caused the A?
It's right there.
I'm going to show it to you in just a second.
It's right there.
I will show it to you in just a moment.
Just there, the F that represents it.
Yeah, so the force. So gravity's not a force. Sorry.
Creates a force, yeah. Gravity's the
So
acceleration.
where did you get the A from? The A needs a force.
Yeah, there's the force.
Yes. So where's the A come from? What's the force?
The A comes from Newton's second law.
So where's the force that gave you the A?
Right there.
No. What force gave you the A?
That force is the F equals ma.
We're getting rid of the force. Where did you get the A? Rachie.
You can't have the A without a force.
Craig.
Right, yeah.
Therefore, you have no A. Therefore, A equals
Rachie,
0.
Be quiet. So, sorry.
A is 0. Okay. Carry on. A equals 0. Carry on.
No, A does not equal 0.
So now all we got to do.
Obviously it does because you don't have a force for it.
Equal to each other. Now all we got to do is set those things equal to each other, Craig. Ma now equals G M1 M2 divided by R squared.
You can't have A without a force.
According to Newton, it's right here.
Over R squared. This is Newton talking here, right? Yeah.
How did you get the A? Show me the A. Right. How did you get the A?
We got it from Newton's second law.
Now, cancel.
Where? Show me the A.
Right there.
We're trying to, Rachie.
Yeah, now be quiet. Yeah, be quiet. Right, Rachie, just be quiet and have the maths lesson for a sec.
Cancel the M1s. Divide by M1 on both sides. Bingo.
Right, so
yeah, I still don't see where you got the A.
You end up with A is equal to G times M2 divided by R squared. There's where the A comes from.
Newton's second law.
M2.
So there's a force.
That mass.
How did you get the A?
Where the A comes from.
How did you get the A without a force?
The A is in Newton's second law, as you keep telling us.
Okay, and how did you get the A?
From Newton's second law.
You keep saying Newton's second law, which is F equals ma. Okay, fair enough. Where did the A come from? What caused the number? Math.
The A comes from, as we can show you here, the A comes from G times M2 over R squared. That's where we get the A from.
The what, sorry?
as like so you've got F equals ma and Fg equals gm1 m2 over r squared. Okay, cancel out the force, you get ma over ma equals g m1 m2 over r squared. Cancel out the m1s, you get ma over m1 equals g times m2 over r squared. So a, which is this a that we're looking for, comes from g times m2 over r squared. That's where you get the a from.
Okay, so where did you get the a from? Where's the g? What, do you mean the big G or the little g? Because I can't really see the screen.
Told you that there, right? So a equals the gravitational the universal gravitational constant times the second mass over the distance between the centers, and that's how you calculate.
So you don't need a force for acceleration.
The stars are a big problem for flat Earth. In the northern hemisphere each night, we see the stars rotate anti-clockwise around a single point in the sky, the North Star Polaris, showing that the axis of rotation of our planet is in alignment with that star. But that's not the biggest problem for the flat Earth. The biggest problem is that as we cross the equator and head into the southern hemisphere, we find out that Polaris has disappeared beyond the horizon, and now we have a new center of rotation, a second circumpolar star, where the stars appear to rotate clockwise around it. The only explanation possible is that we live on a sphere that is spinning. You know.
I believe the North Pole is one side, South Pole is the other side. So then obviously the North Celestial Pole and the South Celestial Pole are rotating. And then let's say you're at the equator between the two, you look towards the North Pole, you see it rotating anti-clockwise. You look towards the South Pole, you see it rotating clockwise. There's your differences done. They're rotating the same way, but they appear to rotate different ways. And that's how you get clockwise and anti-clockwise on a flat Earth with celestial poles. Stop using it as evidence of globe Earth, because it's not. It's not proof. It's not evidence. It can happen on a flat Earth.